The first of the classic spatial disorientation scenarios occurs when a non-instrument rated pilot transitions from visual meteorological conditions into instrument meteorological conditions. Despite the admonition, VFR not recommended, during the weather briefing, the pilot confidently presses ahead on the daytime cross-country flight. But the weather begins to worsen. Before the pilot realizes it, visual contact with the ground is lost. The airplane has entered IMC. The pilot tries to focus on the instruments, but those few hours under the hood during primary training were a long time ago, and what the instruments show is completely different from what the pilot feels. Airspeed is increasing, the altimeter is unwinding, the symbolic airplane is leaning to one side. The instruments indicate the start of a spiral. Sensing only the descent, the pilot reacts by pulling back even harder on the yoke. But things just get worse. The pilot's mind races as the gravity of the situation sinks in. The second scenario also involves a non-instrument rated pilot, this time on a night flight over water or over a sparsely populated area. It's a dark, moonless night with little contrast between the sky above and the ground below. It's hard to tell where the stars end and the scattered points of light from the ground begin. To the pilot, it looks and feels like the airplane is flying wings level, maybe even in a slight climb. The instruments, however, show the airplane banked to the left and starting to descend. Reacting to the instruments, the pilot snaps the ailerons to the right in an attempt to level the wings. The instruments indicate the pilot is doing the right thing, but the pilot experiences the strong sensation that the airplane is actually overbanking to the right. Ignoring the instruments now, the pilot instinctively reverses the aileron input. The airplane rolls back to the left. At the same time, the ambient noise level increases as the airplane starts spiraling earthward. Confused by the conflicting information between what the pilot is sensing and what the instruments are showing, the pilot freezes on the controls. The last of the spatial disorientation scenarios involves an instrument-rated pilot on an instrument flight plan in IMC conditions. The flight seems to be going well when air traffic control notifies the pilot that the airplane is deviating from its assigned heading and altitude. Surprised by this radio call, the pilot places renewed focus on the attitude indicator and directional gyro, both mounted in the center of the instrument panel. According to these instruments, the airplane is still wings level and on heading. All the supporting instruments, however, indicate otherwise, and continually missed in the pilot's instrument scan is the vacuum pressure gauge, which has read 0 for a while. ATC again warns the pilot about heading and altitude. The pilot now fixates exclusively on the slowly failing attitude indicator and directional gyro. Nothing else seems to matter. These accident scenarios share a number of common traits. First, warning signs of potential trouble when unheeded by each pilot. Second, as the scenarios unfolded, conflicting sensory information and instrument indications led to confusion in the cockpit. And third, situational awareness eventually collapsed to tunnel vision, rendering each pilot unable to identify and cope with the developing unusual attitude. To understand the underlying causes of spatial disorientation accidents, we've enlisted the help of 3 guest experts. First, we'll talk with former space shuttle astronaut, naval aviator, and sport airplane enthusiast Robert Hood Gibson, and his wife, former astronaut Dr. M. Ria Seddon.
The overwhelming majority of spatial disorientation accidents result from overconfidence, which then leads to poor decision-making on the part of the pilot. This is particularly true in cases involving flight from VFR conditions into instrument conditions. And the majority of these spatial disorientation accidents result in a fatality. When it comes to critical flight decisions, pilots should ask themselves the following questions. Am I making this decision based on all the available objective information? And am I allowing a hazardous attitude to influence my decision? If the answer is yes to that second question, figure out the attitude that's in play and eliminate that from the decision-making process. Pilots should always try to err on the side of caution. The focus of instrument training, both in the Navy as well as at NASA, was always on the fact that you must rely on your aircraft instruments. You cannot trust your senses at all in these kinds of situations. And there were a great many places, such as out over the middle of the ocean at night around the aircraft carrier, where there was nothing else out there to help you. Nothing lighted, no ground reference, nothing that would help you other than your aircraft instruments. So you must rely on those.
Under certain conditions of flight, our human senses can betray us. Our human sensory systems have limits that all pilots need to understand. Of all our senses, we rely primarily on our sense of sight for information.
And I think you learn that when your eyes are not giving you all of the information that you need, you become dependent more on other sensors in the body. And of course, pilots all fly by the seat of their pants, which sort of means that you get a sensation from your nerves and your muscles and your skin about where the pressures are coming from or where gravity is acting upon you, and you become sensitive to that fact and you begin to listen to that a little bit more. Of course, the gravity sensing organs in the body, the ones that are really specialists in sensing gravity, are in the inner ear.
The most dangerous illusions contributing to spatial disorientation are related to our motion sensing system.
There's a sensation called the leans that most pilots become aware of, and the problem is frequently you're going along level and you go into a bank, and it's very difficult for the inner ear to sense a very slight bank of, say, 2 degrees or less, and the otoliths may pick it up or may not, and the little hair cells bend with that acceleration. But then after you've been in that bank for a while, the otoliths tend to become less responsive and sort of go back to a neutral position. So you can be in a slight bank and feel that you're really level, and you may get into a bank to the point where you feel like you need to come back up to a level, but it feels like you're going the other way. There's also a condition called entering a graveyard spiral. Sometimes pilots can't sense the fact that they're in a very slow roll rate, and they may progress into a descent, and they can really only sense the fact that they're descending and tend to pull up, and really what they're doing is they're rolling, and they are not sensing that component of the acceleration, and that frequently can lead to something called a graveyard spiral, in which they can spiral into the ground because the sensation is fooling them. Vertigo is another thing that pilots worry about and should. Often when your head is in the cockpit and you are scanning instruments or looking at maps and make a rapid head movement, the fluid in the inner ear can begin to move, and because of the confusing situation, you can develop vertigo, meaning dizziness. And there's a problem with that because you may become dependent on what your inner ear is telling you, and really it's sending very confusing signals. And so when you get into a situation like vertigo, it's very difficult to ignore the sensation of that you're spinning or that things are moving rapidly, but it's really only taking place inside your inner ear. It's not happening with the airplane.
Over the years, writing weather en route. The briefer is unequivocal, VFR not recommended. The pilot is not instrument rated, yet is confident based on handling similar situations just fine in the past. The weather worsens, the the pilot presses on, believing nothing bad will happen. The airplane enters IMC, the pilot tries to transition to instruments. But the airspeed is already on the rise as the altimeter unwinds. The attitude indicator, directional gyro, and symbolic airplane all show the airplane in a turn. The pilot only senses the descent and pulls harder on the elevator. The graveyard spiral tightens. It's a moonless night with ambiguous ambient lighting conditions. The pilot is non-instrument rated and attempts to mix contact flying with instrument flying. Visually, it appears the airplane is wings level, perhaps climbing slightly. The instruments indicate the start of a left descending turn. The pilot overreacts to the instruments with a rapid roll to the right. The resulting fluid movement in the pilot's semicircular canals triggers the leans. Reacting to the sensation of overbanking, the pilot returns the airplane to the attitude that feels correct. The cockpit noise level increases as the graveyard spiral gathers momentum. The pilot is instrument rated and is flying in IMC. The vacuum pump fails, the vacuum gauge drops to 0. But the pilot's instrument scan has progressively gotten lazier, fixating more and more on the attitude indicator and directional gyro. The supporting instruments show the airplane beginning a slow, descending turn. The pilot senses nothing. ATC warns of altitude and heading deviations. Confused by the conflicting information displayed by the instruments, the pilot focuses on the attitude indicator and directional gyro. ATC issues another warning as the descent continues. Being the pilot in command is not a passive process.